Alrighty, good morning, everybody. Let's take a look at. I think we just had one request to go over something, and that was going over some mass percent and empirical formula stuff. For whatever reason, that's there we go. So we can do that. So, creature, relax. We can go ahead and start by doing uh, let's take a look at that first problem on the Spring 19 exam 2, which talks about a fairly complex molecule, or rather a compound, calcium hydroxyapatite. So let's go ahead and take a look at that. The question is asking us what's the mass percent of calcium in that compound, which is Ca5. Oh my gosh. And then there's a hydroxide stuck on at the end. And the creature is just getting very angry today. Go figure. He doesn't like pre-exam reviews, so we'll have to deal with him. So remember, the mass percent of an element in a compound is going to be related to the mass of that element times the number of that element, how many there are in that particular molecule, over the total molar mass. And so we're going to have to go ahead and use our periodic table here. So let's go ahead and find the molar mass of, or the atomic mass rather, of calcium. Here it is. It's 40.08, we'll say. We have 5 calciums in this molecule. The total molar mass here, that's kind of the tricky part, right? So overall, we have 5 calciums plus 3 phosphorus plus 13 oxygens plus 1 hydrogen. That's going to be the kind of important part that you can decipher that chemical formula. So remember, a subscript outside the parentheses indicates that you have multiple of that polyatomic ion. So we have multiple phosphates here. Each phosphate has 4 oxygens. We've got 3 phosphates, so that's 12 oxygens from the phosphate. And then we do have that 1 hydroxy group at the end, which is going to give us that 1 more oxygen. So putting this all together, we're going to have to look up our phosphorus here as well. Phosphorus is over here, 30.97. Oxygen, as we probably know by now, 16. And then hydrogen is 1.008. Alrighty, so we have to put all this stuff together. Let's go ahead and calculate it. 5 times 40.08 plus 3 times 30.97 plus 13 times 16 plus 1.008. Doing all that, we get 502.318. With sig figs, we're probably going to want to maintain. I would say we're going to want 4 sig figs there plus the addition here. So, okay, we're going to probably want to keep that as our sig fig. 4 sig figs, right? So, going back to our formula, we're going to have to put all this stuff in here. Remember, we're not going to round it quite yet. We're going to keep that number whole until we finish our math. So we're going to go ahead and do our calcium, 5 times 40.08 divided by that number. And when we end up as our answer for this problem, we get 0.39895. And if we were to put that into a percent form with proper sig figs, we are going to get 39.90%. And that would be our answer there. And the sig figs will just depend on what molar mass or atomic masses you're using based on the periodic table you're using. So I typically just use 4 sig figs per element, but it's up to you, whatever your periodic table gives you. So Since this one was a free response one, I would have based your sig figs on what you have done as your work. Of course, in a multiple choice exam, you don't have such luxury, but don't worry, sig figs typically aren't going to be a problem because all the answers would probably have the same number of sig figs anyway, so we're good there. Alrighty, let's go ahead and we can do number 2 from this exam too, because that is also going to take care of our empirical formula business. So let's go ahead and do that. So we have asparagine here, which we're told is 36.36% carbon, 6.1% hydrogen, 21.21% nitrogen, and 36.33% oxygen. All right. Remember, when we're given percents, we can just convert those to grams. Relax, creature. You're okay. He's extra grumpy today. Okay. So remember, we can't ever compare grams directly when we're looking at different elements. So we have to convert them all to moles first. So we'll go ahead and use their molar masses to go ahead and convert these guys into moles. Let's see what we get. 36.36 divided by 12.01. We get 3.027, thereabouts. 6.1 divided by 1.008 is going to be about 6, right? 6.052. The nitrogen, 21.21 divided by 14.01 is 1.514, we'll say. And then the last one is our oxygen, 36.33 divided by 16. And that's 2.27. So we have all our moles now. So what we're going to want to do is divide by the smallest number of moles, which is going to be our 1.1 or 1.51. I'm not going to actually do the calculation. Hopefully this will work. This looks to be what we would get just without calculating it, just by using, your brains. That appears to be it. And so since we do have a 0.5 in our answer, we're going to have to multiply all of these by 2. That was something I noticed on a lot of your homework, is when you multiply things by 2, you forgot to multiply all of them by 2. So every single thing here needs to be multiplied by 2. So that means we have 4, 8, 2, and 3. And so the formula for this would be C4, H8, N2, O3. And that would be our kind of answer there. Alrighty. So, any questions on those ones? So it looks like that was it for people asking questions. So hopefully this will at least kind of get you to remember these sorts of things. If not, well, I'm still available for general questions, written ones at least, through Discord over the weekend. Other than that, if there's nothing else, I guess we're good. So enjoy your weekends, everybody. Study well. And I'll see you on Tuesday.